Welcome to God's Country Casino, where we are going to be playing a few hands of blackjack to estimate the probability of winning a hand and winning money. So, let's take you over here so we can explain the rules of blackjack. My assistant would so kindly explain the rules.
Each player receives 2 face cards and competes against the dealer to achieve 21 or close to. When the cards are dealt, the dealer's second card is face down. On each player's turn, he or she has the option to request another card by saying hit in order to get closer to 21 or achieving 21. If not, if the player is content, then that player can just say stop or stay if they're actually content with what they have.
Okay.
I'll turn it back to the dealer.
Thank you. Okay, so each card has a value, a numeric value, that indicate, well, okay, let's just explain the values of the cards here. Cards 2 through 10 are worth their numeric value. So 2 is worth 2 points, 10 is worth 10 points, etc., etc. Face cards, which are Jack, Queen, and King, are all worth 10 points. And the ace is worth either 1 point or 11 points. And as you'll see later, you can choose which value you want for your hand. Okay, so I'll bring it back over here to the table, where we will play one game to demonstrate. 9, 8, Queen, King, 7, Queen. Okay, let's bring it to you. Do you choose to stay or hit?
Stay.
Stay. Now, this player right here has 2 face cards, a king and a queen, each worth 10 points, and he has 20. Now, 20 is very close to 21, so I think he's content with his hand and he chooses to stay. Come over to player 2. We have 19.
Here, so I hit.
Hit! We've got a very risky player. I'm sorry, sir. Bust. Now, when you go over 21, you immediately forfeit the hand. You lose. So, I'm sorry, sir. And over here to player 3. He has 18.
I choose to stay.
Smart choice. And the dealer, 13. Now, if the dealer has less than 17 points, he is required to stay by the rules. He's required to hit. Sorry. So, 13, 20. Now, since he has more than 17, or more than 16, I should say, he must stay. So he has 20. Player 1 over here also has 20. Now, in the event of a tie, if we were playing with money, he would get his money back, and it's called a push. Now, he, if we were playing with money, would have already given the money to the table. Now, he unfortunately loses. He has 18, the dealer has 20, so he would lose that hand. Okay, so here in this situation, we're going to try to calculate the probability of player 3 over here getting blackjack. And that means getting an ace. An ace in this situation would be worth 11 points, and on top of his jack that is worth 10 points, he would hit 21 just after 2 cards and immediately win the hand. So, using the information on the board, we can calculate this probability. Now, seeing as we're only using one deck, that would mean that there are only 4 aces in the deck. clearly, no aces are already on the table. So, 4 aces in the deck. There are already 1, 2, 3, 4, 5, 6 cards out on the table, meaning if we're playing with a regular deck of 52 cards, there's 52 minus 6, 46. Yeah. 46 cards left in the deck. So we can say that there is a 4 out of 46 chance that player 3 is going to get blackjack. Let's hope he's lucky. Wow, would you look at that? Blackjack. So.
Simulation, the imitation of an operation or of a real-world process that represents the operation's characteristics or behaviors.
So we use it's really hard for us to calculate the certain probability of the winning in the blackjack games. So we use the simulation to simulate the trials, and we can estimate use the outcomes to approach the certain probability of the winning chances.
Okay, so over here we've got a set of data. After playing 20 hands of blackjack, we tally the number of times each individual player beat the dealer, and using this data, I think we're going to average 3 sets of wins to loosely approximate the probability of winning in blackjack. So player 1 won 7 times, and players 2 and 3 each won 6 times. If we average those 3 numbers together, we get 6.3. So on average, the players won 6.3 out of 20 times. Okay? And 6.3 divided by 20 is 0.315. So using this data, we can roughly estimate that players will beat the dealer 31.5% of the time. Now, okay, so it isn't necessarily within our capabilities of running an accurate simulation of thousands and thousands of games of blackjack to determine the probability of winning, but there do exist many programs that can do this. Okay, so we looked up the actual probability of winning any given hand in blackjack for the player is 43.1%. Now, comparing that to our data, we came up with 31.5%, but we only played 20 games. Now, if we were to play 20,000 games, our calculated probability of winning any given hand would be much closer to 43.1%. So if we were to, again, hypothetically, play 20,000 hands of blackjack, we'd be interested in collecting this data and making a histogram of the results to get a very accurate probability, a very accurate calculated probability of winning any given hand. And he will explain this.
Okay, look at this table. This means the probability of winning the games, and this means the number of the games. And according to the law of large number, when we do the trials in a very small amount of numbers, the variance will be very big. So there is like a wave here. But when we do it like 1,000 times, the variance will much more become closer to 0, and so the probability will become like a constant like this.
Why, may you ask, is the simulation important? Well, I'm here with the God Country's owner, Javier Jones, and he's going to fill us in how the statistics and simulation is going to be important to a casino owner.
So why is this important to the casino? It is important to the casino because essentially we're winning 60% of the time which essentially means that we get 6 of your $10, which is left to the only $4 to the player.
Alright, so thank you for joining us here at God's Country Casino, and we hope to see you back real soon. Blackjack!